Let us look at this whole economic order quantity and the Q model using an example. Let's say I have an annual demand is 1000 units. The average daily demand, which is the D bar, is 2.74 units. The ordering cost is $5 an order. Holding cost is 1.25 an order. Lead time is 5 days. Cost per unit is $12.50. We're going to use the two equations, Q-opt equation, which we know, and then the reorder point equation that we saw in the last slide. The Q-opt is going to be equal to square root of 2 times demand, which is 1000, times the ordering cost or the setup cost, $5, divided by the holding cost, which is $1.25. That comes to 89.44. The reorder point is going to be equal to the average demand, which is daily, that is 2.74, times the lead time, which is 5, and that comes to 13.7 units. So your policy here is going to be, when the inventory reaches 14 units, you're going to order 90 parts or 89 parts. If you want to go up, you can say 90. If you want to make it 89.44, 89. I usually go with the round up, which is 90 parts. Okay, because it's not a big deal of ordering one more part, which you need anyways. Now you can calculate the total cost using this equation, and you plug in these numbers, you're getting, this is a total cost of inventory, $12,611.81. Here we can establish safety stock levels as well. Safety stock, as you know already, is the amount of inventory carried in addition to the expected demand, and they are determined using different criteria. A common approach is to simply keep a certain number of weeks of supply needs to be in the safety stock. But a better approach is to use the probability. So to determine probability, we are going to think of a normal distribution. We're going to think about a normal distribution. We're going to assume a normal distribution for the expected demand. So now I'm going to take safety stock into consideration in my Q model. So if you do not have safety stock, you can go with this. If you have safety stock, this is what we are going to consider. What happens here is this. I have a safety stock. Look, my reorder point is above the safety stock. Think of that. So I need to take that safety stock into consideration all the time. I have the same lead time consideration, and I have the same Q consideration. Okay? If the demand is variable, which usually it is, but then if it follows a particular distribution, like a Poisson or an exponential or linear, whatever the distribution is. So as we reach, this is the point where I bought all my inventory. As we consume, it is going to go down depending on the distribution. And at one point where there is a reorder point, that reorder point is not the stock out lead or based on lead time, but it is the It is the safety stock based on lead time kind of a thing. And that reorder point, we got to calculate. At that reorder point, I order more of this inventory so that I can bump up my inventory to the level of having the safety stock as well as enough stock for my consumption again. That is the whole theory behind this fixed order quantity model with safety stock. So the fixed order quantity model with safety stock includes this probability in the equation, where Z is the number of standard deviations for a specified service probability. So whether it is 70% service probability or 90% service probability or 95% service probability, we need to find Z. And then the sigma L is the standard deviation of usage during the lead time. So if we go back here, this period here, what is the probability of usage in this period is the sigma L. So we need to take that into consideration when you're doing the reorder points. So if you're going to do the safety stock, if you have a safety stock in mind, then you need to use this portion to find the reorder point. The quantity is always the economic order quantity, which is going to be 2ds over h. So let's calculate with an example. I have an average daily demand D is equal to 60. My annual demand is 21,900. The standard deviation of demand during the lead time is 7. This is given to you. The ordering cost is $10. The holding cost is 50 cents. And the lead time is 6 days. You can use the EOQ to find the optimum quantity, which comes to 936 units. We need to calculate the sigma L. The standard deviation of demand during the lead time is sigma D. So to calculate sigma L, we need to use the variance, which is sigma D squared. This is a variance. The variance times the lead time, and then take the square root to find the standard deviation. So sigma D is the standard deviation of demand during the lead time. L is the lead time. So you take the variance of demand during lead time, multiply by the lead time, and then take the square root of that to get the standard deviation. That comes to 17.15. For a 95% service probability, we are going to get Z equal to 1.64 from Appendix E. And Appendix E, you can get the Z for 95% probability, and that comes to 1.64. If you plug in all these numbers, you get to 388 units. So what is the policy right now for this company? You're going to place an order of 936 units whenever the stock falls to 388 units. So this gives you the 95% probability of not stocking out during the lead time while having the safety stock. So let's go to P model. The P model is basically fixed time period model. Here, inventory is counted only at particular times. It could be every week, like Monday morning or Sunday evening, or every month on the 28th of every month. in the evening, or the third Sunday of every month, whatever you want to pick. That will be the time at which the inventory will be counted. You physically count it. Or you can actually use, nowadays, you can use technology like scanning and 2D matrix and barcodes and those smart cards or smart tags, RFID. All these things can be used for counting the inventory. Then you generate order quantities that vary from period to period depending on the usage rate. We assume that the inventory is counted only at the time specified for review. That is the date, the time that we came up with, maybe the February 28th evening or the third Sunday of every month. Safety stock must protect against stockouts. That is another assumption we're going to take. Here, the equation for Q is different. It is not the EOQ, but here it is going to be based on the demand, the lead time, the time T, which is the review time, the sigma, which is the standard deviation for a specified service level. Then we're going to find the sigma, the standard deviation of demand during the review as well as the lead time. So there are two things here that we need to think about. And then what is the current inventory I? We're going to be using this equation for P model. The P model is simple, as we talked about before. You have some inventory as you consume. You place the order at a particular time period, and then it comes, and then the inventory goes up, then again you stop consumption, so on and so forth. So let's take an example. The daily demand is 10 units. The daily standard deviation is 3 units. The review period is T is 30 days. Lead time is L, which is 14 days. You're going to look for a 98% of demand to be met from items in stock in order to avoid stock out. The units in inventory, current units in inventory is 150. So we're going to first find sigma TL. The same way we found sigma L, we're going to find the sigma TL. We're going to take the variance of the the demand, the standard deviation, and we're going to find the variance and multiply that with the time plus lead period, the review period plus the lead period, and we're going to take the square root of that. That comes to 19.9. Then we're going to plug that value into this using the Z for 98%, that is 2.05. So 10 times 30 plus 14 plus 2.05 times 19.99 minus 150 gives you 331 units. So the policy here is that you're going to be ordering 331 units. And the review period is going to be 30 days. So then at the 30th day, the review period day, you're going to be ordering 331 units. Now, the next review period, depending on your I, or depending on anything else that you have, demands and things like that, this 331 will change. And this 331 will change over a period of time. So inventory management basically has got two things that you're going to look at. One is the accuracy of inventory, how well the inventory records agree with physical count. This is important when you're talking about a P model. The cycle counting, the physical inventory taking technique in which inventory is counted on a frequent basis rather than once or twice a year, is the cycle counting. that is also needed